Hi everyone, in this video we are going to see about the bus arbitration algorithms. This comes under the topic multiprocessor architecture. We know that any processor share many of the devices and the memory locations or memory devices. So now the bus, we know that the bus are of three types: address bus, data bus and control bus. Now the system bus takes the control of this any of the devices whichever is wanted to share the data or transfer the data. So let us see what is inter-process arbitration. So as there are many processes, there should be an arbitration, that means changing between the control of the buses changes between the processes and the devices. So what is inter-processor arbitration is? It is the procedure by which the active bus master accesses the bus, relinquishes control of it and then transfer it to the different bus seeking processor unit. That means there are many devices which seeks the bus. So once the particular processor got the control of the bus, it will transfer data and then it will relinquishes, that means releases the control of it and then it transfer the same control to the some other unit which is requesting the service of the bus. And there is a bus master. It is a controller that can access the bus for a given instance. That means for a particular period of time the bus control is given to one of the processor, that is called as a bus master, that controls the access of the bus. In conflict, what is the conflict is when there are multiple DMA controllers, other controllers and other processors attempt to access the common bus simultaneously, that only one is permitted to access. That means here the simultaneous access is not possible, so only one can get the control of the bus. So when many processors or many resources request the bus, there occurs the situation called conflict. So this conflict has to be solved by the bus master. So the bus master status can only be held by one processor or controller at once. That means at the time only one processor can get the control of the bus master. By coordinating the actions of all the devices seeking memory transfers, the bus arbitration method is used to resolve these disputes. So what is the dispute here is many devices accessing the or requesting the control of the bus. So in that case the bus master or the bus controller controls these access, so that this bus arbitration method helps to solve the disputes that come across the processes. Let us see what is the inter-process arbitration. It is a mechanism that is needed to handle multiple requests for the bus, known as inter-process arbitration. So a mechanism that helps to handle. So multiple requests means many, as I just explained before, many devices request the bus. So how to handle those multiple requests is done by the arbitration, inter-processor arbitration, as the arbitration of the buses between the processes, many processes, that is called inter-processor. Arbitration procedure serves all the processor requests based upon the established priorities. So the devices are set some priorities. Based on those priorities, this procedure is handled so that the processor requests are satisfied. So how it is done? There are two different techniques. The arbitration techniques are of two types: static arbitration techniques and dynamic arbitration techniques. What is the static arbitration technique deals is, it has the priority assigned fixed. That means the priority is assigned used based upon some procedure or the calculation. So there are two types of this static arbitration technique itself. They are serial arbitration procedure and parallel arbitration procedure. So what does it mean? So as the name implies, serial means the priority is given one after the another, and parallel means the priorities are handled together. So that is the difference between the serial and the parallel arbitration logic, but both come under the static arbitration techniques. That means there are some priority already fixed by the procedure. Let us see what is the bus arbiter. The bus arbiter decides who would come the current bus master. That means the bus control is given to which particular device. That is the purpose of the bus arbiter. It decides upon this factor. Now, how the arbitration techniques are done? There are two approaches, namely the centralized bus arbitration and distributed bus arbitration. What is centralized bus arbitration is a single bus arbiter performs the required arbitration. That means there is a common single bus, and this single bus arbiter, it alone does the required arbitration. That is centralized. There is only one single control. But whereas in the distributed bus arbitration, every device has its own arbiter. All devices participating in the selection of the next bus master. That means bus master is the one who get the control of the bus, and all devices participate in one or the other way how to select the next bus master. That is the procedure done by the distributed bus arbitration. So as the name implies, centralized bus arbitration, it is given to a single bus, whereas it's a single device. Under the single device control, the arbitration is chosen, but in the case of distributed bus arbitration, all the devices participate for the selection. Now let us see some signals of this bus arbitration. They are bus request and then common bus request. The bus request is the request given for the particular device, and there is always a common bus when there are multiple processes in this architecture. So the common bus is requested by the CBRQ signal, and when the bus actually the bus will be busy as well as it will be idle. So when the bus becomes busy, other processor cannot access the bus. So the bus has to give an indication as busy signal. Okay, so then only other devices understand that no other device can access the particular device, the bus, for some unit of time or some period of time. So they have to wait, or it will do some other process of its own. And now the bus clock, B clock, is the another signal which has the synchronized, which helps to synchronize access of the different bus arbiter signals. And next is the bus priority in and priority out. So which device gets a priority, it is given by the input BPRN, and once the priority is over, it will be given out to the next consecutive devices, and that is done by the BPRO, which is the bus priority output. So by these 6 signals, this bus arbitration takes place. Let us see the serial arbitration. The diagram of this, it is also called as a daisy chain arbitration. So what does it mean? Here we can see here there are different devices and different buses are there, and there is a bus busy line commonly connected to all the arbiters. There are arbiters 1, 2, 3, 4, and it will goes on and on based upon the device specification. So now we are having the input I, and from that input it is given to the PI. PI is the priority in. So here this line goes from higher priority to the lower priority. So the highest priority first get the input signal from outside any other bus controller or the arbiter, and once it get the control, it will pass on. If it is necessary, that bus device will be enabled, otherwise it will disable its bus, and it will pass the priority to the next consecutive device. Okay, likewise the priorities passes from one to the other. It is called as a serial arbitration. That means the device which is in the 4th will get the chance only after it is checked by the arbiter 1, 2 and 3. So there are some advantages and disadvantages of this particular arrangement. Let us see the advantages and disadvantages. So this is the diagram that says about the priority is passed from one arbiter to the next arbiter, from the highest to the lowest priority. Okay. Now let us see the advantages and the disadvantages of this arrangement. First, it is a simple design, and then it is a less common control lines are used. So that is the advantage of this one. And the disadvantage here is that priority depends upon the physical location of the device. That means the first device get the first priority, which is placed near to the bus controller or the arbiter. Then as the devices are far away from the bus arbiter, accordingly the bus arbitration procedure selects in a sequential fashion, means one after the another. That means the device which is in the last will get only the after some period of time. So the propagation delay will be there due to the serially granting of buses, because it first checks whether it is given for the arbiter 1. If it is needed, it will process it, make its bus busy and others as disabled, otherwise it will pass the control to the next consecutive device. So suppose the nth device will get the control only after the n minus 1 arbiters say it don't want the buses, after grant the control of the buses. And the third disadvantage is failure of one of the devices may fail the entire system. What does it mean is, suppose the arbiter 3 fails. So the priority comes from 1, 2 and pass to 3. Okay, but now the priority is not needed for arbiter 3, but arbiter 5 may be expecting the control of the bus. At that time, the priority has to be passed to the arbiter 5, but it can go only one after another, which is from 3 to 4 and 4 to 5. But in case if the third arbiter fails, it cannot pass the signal to the consecutive arbiter. That means the failure of one of the devices will fail the whole system. That is the disadvantage of this particular arrangement. And the last one is cannot assure the fairness. A low priority device may be locked out indefinitely. What does it mean is, a priority which is low, which is in the last of the line, will not get the device control for long time, though its process may be urgent. So that is the it's not a fairness case. So that is the problem in the particular type of serial arrangement. So let us see the parallel arbitration method. In this method, here we can see the encoder as well as the decoder. Okay, so in the decoder, so we can see here the buses have the control. Here we are having the acknowledgement and the request. Okay, so as the request is needed, so naturally the lines will be shared. Now we can see here bus request and bus acknowledgement lines are there. The here down is the decoder and up is the encoder, priority encoder. So now the priority encode is a 4 by 2. That means there are 2 by 4. That means 4 lines are 4 arbiters are there. Arbiter 1, 2, 3 and 4. Among it will be selected 1. Okay, that is 4 by 2. And we are having the acknowledgement and request signal. We can see here the decoder is connected. Priority controller, it contains it connects all the request. Okay, the bus common bus busy line is here, and from the bus busy line and also from the request, the priority controller got its input. You can see here direction which is from the request as well as the control is from the common busy line. There is a bus busy line is there, and the 4 inputs are from the request line, which is to the 4 by 2 priority encoder or a controller. Then from there it's a decoder. It controls the priority, and after this it is select among the 4, it select 1 that will be passed to the next device, which is the 2 by 4 decoder. This decoder decides whether the arbiter 1 or 2 or 3 or 4 will be selected. So for that it has the logic. All the output of this decoder goes as the acknowledgement input of all the arbiters. So based upon the input given, whatever the priority or arbiter is chosen, accordingly particular arbiter will be enabled. So even the control is given parallelly to everything, but based upon the decoding technology as well as the priority controller, the corresponding arbiter will be selected based upon some logic inside. So this is called as parallel arbitration. That means here at any time any arbiter will get the control. It is not that arbiter control has to pass from 1 to 2 to 3 and then and 4 and so on, like the serial arbitration. Here it is based upon purely upon the decoding technology. Let us see what is the advantage and what is the explanation for this. It uses an external priority encoder and decoder, just seen as a block diagram, and each bus arbiter has a bus request output line as well as the bus acknowledgement input line. So the request comes outside, it is the output line, and the acknowledgement is received, it is the input line. So every priority has an acknowledgement and request line. Each arbiter enable request lines when its processor is requesting the system bus. So whenever the processor needs a system bus, the controller automatically enables the respective arbiter. So that will enable the bus control for its own device. The one with the highest priority determined by the output of the decoder gets access to the bus. So this is not like the case of the serial case. The priority passes from 1 to 2, 2 to 3 and 4 and so on. Naturally, there is a logic which determines the priority of the arbiter, which is done by the decoder output to get the access of the bus. So that's all the different technology of how the arbitration takes place either serially or parallelly. It all comes under the topic of multi-processor architecture organization. So when the question is asked for just a static procedure or a static arbitration technique, it is enough to mention these points in your answer sheet. Hope it is easy to follow, and thanks for watching.